Good morning all of you. Yesterday we were talking about combination of resistances and we have talked about series combination of resistances. So today we are going to study about parallel combination of resistances. Resistance in parallel. So when two or more resistances are connected between two common points so that the same potential difference is applied across each of them, they are said to be connected in parallel. That is, when two or more resistances are connected between the same point so that same potential difference is applied across each of them, then they are said to be connected in parallel. And according to the law of combination of resistances in parallel, the reciprocal of the combined resistance of any number of resistances connected in parallel is equal to the sum of the reciprocals of the individual resistances. Like this, 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. So when two or more resistances are connected in parallel, the reciprocal of the equivalent resistance, that is 1 by R, is equal to the sum of the reciprocals of all the individual resistances. Now when a number of resistances are connected in parallel, then their combined resistance is always less than the smallest individual resistance. For example, if two resistances of 5 ohm each are connected in parallel, then the equivalent resistance 1 by R is given by 1 by 5 plus 1 by 5, which comes out to be 2 by 5 ohm. And when we reciprocate it, we will get the value of R as resistance as 2.5 ohm. So here you can see, when the resistances are connected in parallel, the equivalent resistance is always less than each of the individual resistance. Now let us see the derivation of the law of combination of resistances in parallel. Consider three resistance R1. Consider three resistance R1, R2 and R3 connected in series. Now suppose the current across resistance R1 is I1, R2 is I2 and R3 is I3. Let the total current in the circuit be I. Then the equivalent current will be given by I equal to I1 plus I2 plus I3. And when we apply Ohm's law to the whole circuit, we know that current will be equal to V by R, where V is the potential difference and R is the resistance. Now apply Ohm's law to the three resistors separately. We have to apply the Ohm's law to the three resistors individually. So we get, when we apply Ohm's law to resistor R1, we get I1 equal to V by R1, where V is the constant, I2 equal to V by R2 and I3 equal to V by R3. And when we substitute these values in this equation, we get this equation. In place of I, we can write V by R. In place of I1, we can write V by R1. In place of I2, we can write V by R2, and in place of I3, we can write V by R3 from equation number 2, 3 and 4 respectively. So in this equation, V is common on both the sides. So we cancel out V from both the sides and finally we get this equation. And this is the reciprocal of the equivalent resistance, which is equal to the sum of the reciprocals of all the individual resistances. So therefore we conclude that sum total resistance in a parallel resistance connection is equal to the sum of the reciprocal of all the individual resistances, and this equivalent resistance of a parallel combination is always less than each of the individual resistances. So I hope this derivation is clear to you all. Now the observations made on a parallel combination of resistance. So when two or more resistances are connected in parallel, the reciprocal of the total resistance of the combination is equal to the sum of the reciprocals of the individual resistances. We have just seen that 1 by R will be equal to 1 by R1 plus 1 by R2 and so on. Second is the current flowing through each resistor is inversely proportional to its resistance. That is, I will be inversely proportional to the resistance. Thus, higher the resistance of a resistor, lower will be the current flowing through it. Third is, when two or more resistances are connected in parallel, the same potential difference is applied across each of them and different amounts of current flow through each resistance. So in parallel connection, potential difference remains the same but current varies. Now these are the different ways of combining resistances in parallel and in series. So have a look on these circuits, that how different combinations can be possible in parallel and in series. So this is how the current gets divided when the resistances are connected in parallel. So you can see from a particular point the current gets divided, though the potential difference remains the same when the resistances are connected in parallel. So I hope this topic, combination of resistances in series as well as in parallel, is clear to you all. So tomorrow we are going to start a new topic of this chapter, and meanwhile you can study this topic from your book, and these derivations in series and parallel connection are important, so practice them.